Alright guys, this will be the final sample problem that we will be working with. Let's read it together. A 0.2356 gram sample containing only sodium chloride and barium chloride yielded 0.4637 grams of dried silver chloride. Calculate the percent of each halogen compound in the sample. This is a short problem, but this introduces some new mathematics, because unlike the previous problems, we now contain a question asking for two variables. Since we have two unknowns, in this case the grams of sodium chloride and the grams of barium chloride, we need to construct a system of equations to calculate for these two variables. To see how that will work, let's write down the given. Let's start by saying that the grams of sodium chloride plus the grams of barium chloride should equal to 0.2356 grams. Again, this is a sample containing only sodium chloride and barium chloride, so this shouldn't be too controversial. You could also define variables such as x and y instead of grams sodium chloride and grams barium chloride, but I'm not going to do that here. We know that the chloride in sodium chloride and the chloride in barium chloride got converted into silver chloride, and that's 0.4637 grams. We're asked to find percent of sodium chloride and percent of barium chloride. Let me write down the molar masses once more. Sodium chloride is 58.44. Barium chloride is 208.33. And silver chloride is 143.32. Let's solve this problem. Again, we have two unknowns, the grams of sodium chloride and the grams of barium chloride. So it makes sense to have that as our first linear equation. So let's just copy that. Let's call this equation 1. We need to construct another equation containing grams of sodium chloride and grams of barium chloride so that we can do stuff like substitution or elimination to determine the values for these variables. We know that the chlorides from both compounds are converted to silver chloride. So how do we represent that in terms of a mathematical expression? I know that if I start from grams of sodium chloride, I could divide it by the molar mass. Whoops. That gives me the moles of sodium chloride. I know that there's 1 mole of sodium chloride for every 1 mole of silver chloride. Again, the analyte here, if you haven't noticed, is chloride. So let's ignore the cation. There should be 1 sodium chloride for every 1 silver chloride. Once I have moles of silver chloride, I can then calculate for the grams of silver chloride. So, the grams of sodium chloride from my original sample can be stoichiometrically converted into the equivalent grams of silver chloride that forms part of the final product. Likewise, I can do the same for grams of barium chloride. So, if I put in the numbers necessary, grams of sodium chloride divided by the molar mass, 58.44. We're done with this step. Multiplied by 1. Multiplied by the grams of silver chloride, which is 143.32. It should make sense that this expression is equivalent to the grams of silver chloride formed from sodium chloride. Again, let's think about it. If I start with grams of sodium chloride, divide it by its molar mass, convert it to moles of silver chloride, and multiply it by the molar mass of silver chloride, this expression or this value should give us the grams of silver chloride formed from sodium chloride. You can then add the grams of silver chloride formed from barium chloride. So following the same logic, we can divide the molar mass and multiply the mole ratio. So for barium chloride, there are 2 moles of silver chloride for every 1 mole of barium chloride. Again, because there are 2 chloride ions in barium chloride and 1 in the final silver chloride solid. Now let's multiply by the molar mass of silver chloride. This expression will be the grams of silver chloride formed from barium chloride. It makes sense that the grams of silver chloride formed from sodium chloride and the grams of silver chloride formed from barium chloride should total the final grams of silver chloride. So we now have equation 2. That's 143.32 over 58.44 grams of sodium chloride plus 2 times 143.32 over 208.33 grams of barium chloride equals 0.4637. Now that we have a system of equations in 2 variables, again that's equation 1 and equation 2, we can now calculate for the values of these variables. You can do whatever you want. You can do substitution or elimination. I'm going to use a calculator to make it quick. So I'm going to do a matrix representation. I know that if I input the coefficients of equation 1 in the first row of the first matrix and the coefficients of equation 2 in the second row of the first matrix, take the inverse and multiply with a matrix containing the values of the constants. So it's 0.2356 and 0.4637. I should receive a matrix of values for the grams of sodium chloride and the grams of barium chloride. Let me do this real quick in my calculator. Okay, so this matrix is 0.13147599621 and then 0.10412400379. The percentage of sodium chloride should then just be 0.1314759621 all over our initial sample mass, which is 0.2356 grams, times 100%. That's 55.80%. And if I do the same for percentage of barium chloride, again 0.1041240379 all over 0.2356 grams times 100%. That's 44.20%. Notice that if we add both of these percentages, it should be equal to 100%. So the mathematics checks out. Were you able to follow my calculation? This problem is different because we had to solve for a system of equations. But at the very core of these equations are again just these stoichiometric conversions. All you need to do is to really think about the chemistry or how the moles are converted into other moles. And after that, you could use whatever tricks you know from algebra or mathematics to solve for the equations. I hope this makes sense to you, but if it does not, again, please take your time and really understand the structure of the solution. If you have any questions, please feel free to ask them in our class piazza, and let's just all help each other understand and learn gravimetry. There's no need to rush, but I hope you do your best in trying to understand the lesson. I'll see you next time.